Good afternoon, Science Nines. So I am so sorry. The first recording, I guess, had no sound. So I will try to do my best to remember what I said this morning. I am going to leave the muted video on just because it did have the process on it where I added the chemicals. So you can just look at that when you get to that part. But I will redo the thing. Sorry, we just adopted a dog and our dogs are starting to... learn how to make friends with each other. It's been a process, but we'll get there. So I apologize if there's some barking in the back. But yeah, let's get to it. So today we're going to talk about this structure, our dihydrogen monoxide of water. So we learned in our last unit about the fact that this is a molecular compound. So they are sharing electrons. So we have an oxygen molecule in the middle, and we have two hydrogens on the side. So for those of you that did the candy compounds activity, you actually would have built this structure, and you guys all did that nice V shape with it. And yeah, so they're sharing their electrons between the oxygens and the oxygen and the hydrogens on the side. And we're going to talk about the importance of this molecule. As we know that a majority of our body is made up of water, a majority of the earth is made up of water, and we need it to survive. All living things need it to survive. So it's also the most abundant substance on Earth, which is great because we need it. But the problem is 98% of the water that we have on Earth is actually found as salt water, which is not consumable to us. So we have to obviously alter water and do different things in order to have it consumable by humans and to be used for plants and washing and stuff. Now, the other problem we have with this is that a lot of our water, so only about 2% is fresh water. Of this 2%, a lot of it's contaminated with pollutants. So we need to talk about how much is too much, and again, if it's safe. So we're only going to look at two different things today. We're going to look at nitrates and phosphates, but there are so many more things that can be, your water can be contaminated with. It could cause problems such as heavy metals. And we looked at the parts per million lab the other day. So things like heavy metals can make water undrinkable, and eutrophication, and basically how it accumulates over time, and how levels can actually become quite dangerous for that. So there's two ways that water can be polluted, and we talked about this last week in our lessons. You can have a point source pollution, whereas you know exactly where the pollution's getting added into the water. So that could be an oil spill, that could be a factory that's dumping its chemicals into a river, and then you can point out where that pollution's coming from. Now, on the other hand, we can also have a non-point source or pollution. So this could be just environmental, just basically the environment and how these pollutants get into the water cycle. So industrial areas, again, unless it's directly dumping into an area, just the smog would be a non-point source solution in general, because there's just so much going on. All the cars, right, that we're using that are putting all these different pollutants into the air and stuff like that. So every time it rains, pesticides that are sprayed end up getting into the water. So I actually don't personally spray my dandelions, and the main reason is because if I spray the dandelion in my lawn, that's great because that's my choice. But on the other hand, when it washes away with rain, it's getting into other places that didn't choose to get that pesticide in there. So just be careful with your pesticides. I spoke about this last week on washing your vehicles. If you are washing your vehicles with soaps outside of a car wash, you have to be very careful that it's not going to cause any problems. To add these nitrates and phosphates into our water table, which causes algal bloom. So the problem with this is that what happens is these fertilizers, nitrates and phosphates are also fertilizers, but they are also found in soap. So what happens is when you wash your car, with soap outside of a wash station, because the wash station will dispose of it properly, all the nitrates and phosphates end up getting into the lakes and rivers. So what happens is it fertilizes the algae or different seaweeds in it, and it causes them to grow out of control. So the algal blooms specifically are the ones that are on the top. Now what happens is because there's so much of them on the top, the plants underneath don't get enough sunlight. So the plants underneath end up dying. And then in order for an organism to decompose, it uses oxygen. So the dissolved oxygen that's in the water starts to decrease. So it's going to cause things like animal death, right? So the fish are going to start dying, and some of the plants may start dying, and again cause this problem all over again because decomposition requires oxygen to occur. So the algal blooms not only die and require oxygen to dissolve, but they also block the sunlight, causing the ones to causing the plants on the bottom to die anyway. So it causes this problem in the lakes and rivers. So we have to be very, very careful with what pollutants we're adding into the water and try to reduce our footprint with that as much as possible. Now, there's going to be other things that are going to be found in the water, of course, unless you have pure water. So our control that we're adding is just pure water. So deionized, like there's nothing in it. It's just hydrogen and oxygen, which is rare to find, like just pure water with that. So there's going to be lots of different things in that. So yeah, and sometimes nutrients are good, right? Like phosphates and nitrates are good for our plants. We need phosphorus and nitrogen, right? We also need potassium. We talked about that last week. But sometimes these compounds of phosphates and nitrates can cause problems when we get into our water system. So yeah, so what we're going to be looking at today is we're going to be looking at the manipulation of 3 different types of water. So we are not using pond or lake water. The lab suggested to use control water, a natural water sample, and then a age sample. So I already did the adding. And then what we're going to do is, we're going to compare the 3 different manipulated variables. So we're manipulating our different samples. So our samples are... we have filtered water. So the filtered water is coming from my refrigerator. So it goes through a filter. So it is tap water, but it goes through a filter. So I'm very curious to see how different it is than our tap water. Now, I will say we're only testing for nitrates and phosphates. We're not testing for other chemicals or compounds in it. So there may be a huge difference in it. We just may not see it because we're only testing for the presence or absence of nitrates and phosphates. And then because of this beautiful rainy weather that we've had the past 3 days, I was able to collect as much, lots of rainwater. Obviously, there's just a little of it. So we have rainwater as well. I tried to collect it from a bucket that was quite clean. Now, again, there can be contaminants coming from it in the sense that it is coming off of my shed. So there could be some contaminants coming off from the shingles or from the pipe itself that could be changing the water. So just always keep that in mind with that. We're trying to keep it as controlled as possible, but there's always sources of error. And then our last one that we're looking at is aged tap water. Now, the reason why we're using aged tap water is because tap water has fluorides, chlorides, and different minerals that are in it already. So when you age it, so when you actually have it sitting out for a while, the UV light actually can break down the chlorine in it. So it's not going to kill some of the other things in it because chlorine kills all these a lot of the like bacteria and stuff that gets into your water. So I tried to make it age so that it doesn't affect it in that way because it could actually just kill the substances that we added. So what you'll also notice as a control is that, so these are my 4 for each one. As a control, they all should be about the same level. So you can see that there. And then they are supposed to be in natural sunlight so that they're actually mimicking what would happen in the environment as best as they can. We're not going to leave it outside because of the fact that it could get dirt and things like that. And I am going to cover up the cups with saran wrap right away so that we can prove that nothing got into it that contaminated it. So what I did is I added 10 drops of our responding variables. So basically responding is what you're measuring, which could also be called the dependent variable. So we are measuring for the presence or absence of nitrates and phosphates. So that is called a qualitative analysis. So a quantitative analysis would be when you're looking at how much of something there is. So you guys did that with the parts per million lab, where you guys did the food coloring and you diluted it. So you were saying like, how much is there? So there was 1/10, and then 1/100th, and then 1/1000th as a presence in parts per million. So today we're just checking out the qualitative value, which means presence or absence. So is there nitrates or not, or is there phosphates or not? And again, we'll be able to look at that. And it does take a few weeks to see the full results, so we will be recording and observing as we go along. So what I did is, into each of the three different samples, types of samples, I added 10 drops of the control. So the reason why we add pure water as our control, your control group is normally pure water, is because we want to prove that by adding 10 drops of something from this bottle isn't what caused the change. So I added 10 drops of the control into the filtered water control, the rainwater control, and the tap water control. Then I added 10 drops of the nitrate solution into the filtered water nitrate, rainwater nitrate, and aged water nitrate. Then I added 10 drops of the phosphate solution to the filtered water phosphate, rainwater phosphate, and tap water phosphate. And then I added a mixture of the two, which is a nitrate phosphate solution, which again is going to help us with our control, and we'll talk about that as it comes. But I added 10 drops into the filtered water nitrate phosphate solution, 10 drops to the rainwater nitrate phosphate solution, and 10 drops into the aged water nitrate phosphate solution. So we are going to leave that on the windowsill. After 3 or 4 days of exposure to the sun, we're going to observe the samples in each of the cups and record our observations. And then we're going to add more of the solution again as we go on and do that. So we're going to do this for every 3 or 4 days. We're going to add more and observe and see what happens. And then we will talk about what we see with our results. All right. See you guys.